Hello there, Silverly B here, and today I'm going to be showing you guys how to make this isometric tile board generator. This generator is supposed to be used while on edit mode, so when you're editing your scene, this generator is very good, and if you were to use this to generate tiles during runtime, you might need to do a few adjustments, okay? So let's start working on our generator. The first thing you're going to be needing is the sprites that we're going to be using for this project. Here I have my isometric tile set already imported. I did this tile set on my previous video, and this tile set, along with the codes used on this project, will be available in the GitHub link down in the description. So here, as you can see, I just changed the sprite mode to multiple. The pixels per unit that I used were 33. And I also changed the filter mode to point no filter because this is made in pixel art, and I also changed the compression to none. So these were the changes that I made in order to have all of these tiles right here. If we were to drag and drop our tiles inside of our camera, we can see how they look like. So this will be the base tile that we'll be using on our game. First, we're going to reset its transform and change its name from tiles to only tile. And inside of here, we're going to create a new folder that we're going to call it our prefabs folder. Opening it up, we can drag and drop our tile and create a new prefab with it. We can then just delete this tile here. What we're going to be doing now is an object that will be generating our board. We're going to call this the tile generator. And inside of here, we're going to create a new component that will be our tile generator script. So inside of here on our assets folder, we're going to create a new folder that we're going to be calling scripts. Opening this, we can create a new C# script that will be called tile generator. We can then just drag and drop this tile generator script inside of our tile generator object. So we can see here that the script is inside of our game object. Opening this on Visual Studio, we're not going to use any of this. We're just going to ask for the size of our tile. So a public vector2 that we're going to call size. And also we're going to ask for a public game object that will be our tile. The thing is, we're going to be instantiating our prefab in our scene. And in order to instantiate it, keeping the link between the game object and its original prefab, we have to use prefab utilities in order to instantiate this game object. Because if we just use instantiate, it's going to be instantiating the object without the link to the prefab. The thing is, in order to use prefab utility, you need to create an editor script. To do that, we are going to need an editor folder. So here it is very important that you don't misspell this. This is going to be our editor. Opening it up, we can then create a new C# script that we're going to be calling tile generator editor. And we can open the script. And here what we're going to be using is the namespace Unity editor. And now the base class is no longer going to be monobehavior, it's going to be editor, okay? So inside of here, we're going to create a new function that will be called void generate board. Oh, sorry, I forgot the semicolon here. So now that we have this generate board function, we need a way to call this function. First, let's write a simple message here. So debug.log generate board. And in order to call this function, we're going to create a new button on the inspector, because when we use the editor, we can also edit the inspector. So if we were to save these scripts right here and go back to Unity, we can see on our tile generator that it's going to be asking us for a tile and a size. What we want now is to create a button here that we can press and call this generate board function. To create this button, what we're going to be using is public override void on inspector GUI. And inside of here, we're going to replace this with draw default inspector. Okay, so now what we're going to do is draw a button on the inspector, and whenever we press that button, it's going to be calling our generate board function. To do that, what we're going to be using is if GUI layout here dot button, and here you can name whatever name you want your button to have. In our case, it's going to be generate board. So if generate board is pressed, what we're going to do is we're going to call the generate board function. Saving this, we can head back to Unity and check to see if it's working. So as you can see, there's no button here. This is because I forgot to write an important line of the code. If we're making a custom editor, okay, we need to specify what class uses this custom editor. So here we're going to say custom editor, and this custom editor is type of, and here we write the name of the class that we're going to be using. So in our case, the style generator editor is going to be a custom editor for this class right here. So tile generator. Inside of here, we can just write tile generator. Saving this, we can head into Unity, and here we can see that now it has the generate board button. If we were to press this, we can see down here that the console exhibits the message generate board. So it is working. Now, all we have to do is actually create this function right here. What we're going to be using is first, we need the current tile generator. So here we're going to create a new tile generator that we're going to call TG, and this will be the tile generator that is our target. So the current tile generator. What we're going to do is we're going to loop through tg.size.x, and then we're going to loop through every column, and this time instead of I, the variable is going to be j, and here instead of length, it's going to be tg.size.y, and inside of here, we're going to be instantiating the prefab tile maintaining its link. So prefab utility dot instantiate prefab, and here we're going to reference the tile, so tg.tile. If we were to save this and head into Unity, we can check to see if the script is working. So here we're going to drag and drop our tile, and we're going to be setting a size of 3 by 3. Okay, we can then generate our board, and here we can see that inside our scene there are new 9 tiles right here. So as you can see, they were generated on the hierarchy inside of our scene, and it would be nice to keep this organized if they were inside of our tile generator, because then we can just close this off or get the reference to these tiles from the tile generator and vice versa. So these tiles can get the reference to the tile generator because it's their parent. In order to do that, in order to generate these tiles as the children of the tile generator, we can delete this, head into our code, and now instead of just instantiating it, we're going to keep a reference to this tile that we've just instantiated. We're going to call this var new tile. In order to do that, we need to instantiate this as game object. Okay, so this way we can access new tile dot transform dot set parent, and inside of here we need the reference to the current tile generator, so tg dot transform. So now this new tile is going to be a child of the current tile generator. So saving this, we can head into Unity and check to see if this works. If we were to then generate a new board, we can see here all of our tiles are inside of our tile generator. But if we were to generate a board again, you can see now that there are 18 tiles, because at no point are we clearing this tile generator. And of course, you can just delete this and generate the board again, and our tiles will be 9 again and not 18 anymore. But if every time you're going to be generating a new board, you have to come here and delete these tiles, then it's better to have a clear board function that is called before we generate the new board. To do that, because we now have a link between the tiles that were generated and the generator, it's going to be pretty simple. So here we're going to create a void clear board, and we'll be asking for a tile generator. That will be our TG, and inside of here, we're going to go through every child of TG. So tg.transform.childCount -1. And while this is greater or equal to 0, I is going to be decreasing, okay? So we're going through every child of TG. What we have to do is to destroy these children, okay? So destroy immediate, and it has to be immediate because we're doing this on the editor and not during runtime. So it's destroy immediate, and here it's going to be tg.transform.getChild, and here we have to pass the index of the child, and this is going to be I. And this right here is going to be destroying the transform of the child, because this function returns to us the transform of the child. To fix this, we just need to call the game object, okay? We can call this right after we get tg, so clear board, and this is going to be clearing tg. We can save this, head into Unity, and check to see if our generate board function is working. So here we've generated our 9 tiles, and if we were to generate the board again, here we have our 9 tiles. If we were to change the size of the board, we can generate a new tile board that now has only 4 tiles. Okay, let's go back to 3 by 3. We can generate it and it's working fine. Another thing we can do is we can create a new button. We can copy this, paste it over here, and we can replace generate with clear. And now all we have to do is we have to send the reference to the tile generator that is our target. Saving this, we can see now that there is a clear board button that clears our board of every tile inside of it. So we can generate again. Now all we gotta do is we need to worry about the position of these tiles, because currently they're all stacked on top of each other. So if we were to generate them, they would be all on the same point. To change this new tile position, we just need to say new tile.transform.position is going to be equal to a new vector 3 that will be 0, 0, 0. For now, we're not passing any values here on our vector 3. And before we pass these values, we need to understand how the position on an isometric grid works. The first thing we need to know is that Unity 2D deals mainly with 2 axes, the x and the y, and they are positioned as such. We are creating a board of tiles that will be positioned according to their own axes, that we'll be calling I and j. We can see then that every tile in our board will have a position on the board that we are going to call I and j, and it will also have a position as an object on Unity's 2D plane that we'll be calling x and y. What we're interested in is the distance between 2 points on the isometric grid in order to position them correctly. And we'll be considering that we know their I and j position. If we take a look at our isometric tile, and here we'll only be considering the top part and we'll be ignoring the sides of it, we can see that it has a width that we'll be calling w and a height that we'll be calling h. This width and height can be interpreted as vectors on the x and y axes. So here we'll be using the vector w to represent the width on the x direction, and the vector h to represent the height of our tile on the y axis. Now, considering the distance between 2 points on the board that have the same j, we can clearly see the influence that the I position will have on the tile. Here, it will be negative because this is going in the opposite direction of the h vector. We can do the same for j and see the distance between 2 points when the I is the same for both of them. And the only influence on their positioning is their j position. This time, both of these vectors will be negative because both of them are going on opposite directions from the h and the w vectors. So the distance between two random tiles that we'll be calling P1 and P2 according to their x and y position on Unity can be expressed by this equation. Now, the distance between two random tiles can be described as such. We can then rearrange this expression so that we can finally get the influence of the I and j on the x and y position of our tile inside of Unity. Since we're not just simply trying to get the distance between 2 points on the isometric board, we're trying to get their position from the origin, where I and j are going to be equal to 0, and we can also consider that x and dy position of the origin is going to be 0 as well. We can simplify this expression that we have right here. So we'll be left with this expression. In order to get the x and y position of a tile on the 2D plane on Unity from their I and j position on the board, we can simply use this equation and get their position. Now, let's go back to the code in order to implement this. Okay, now that we can understand how the position on an isometric grid works, what we're going to be doing is here for our x-axis, this is going to be I minus j, okay? And this is going to be multiplied by half the width of our tile. The thing is, sometimes I prefer to manually set the offset that the tile is supposed to have, because then I can have more control on how my board is going to be looking like, and to have a manual value that I can set here as the offset. What I'm going to do is here on our tile generator class, I'm going to be asking for a public vector2 that will be our offset. And this is just to have more control on the position of the tile. Inside of here, I'm going to be multiplying this by the tg.offset.x. So the offset for the x-axis, and inside of here, it's going to be minus I plus j multiplied by tg.offset.y. We can then save all of our scripts and head into Unity. We can now see on our tile generator that it asks us for an offset. I'm going to start with an offset of 1.5. And normally what we're going to have here is a y value that is half the size of the x value. And you could use only one float. This way you would ask only for one value. And for instance, it could be the x offset. And to work with the y offset, you would just divide your x offset. But I prefer to have these two values because then I have more control over how it looks. Because again, you can then customize it more. If we were to generate a board with these values, we can see that it's almost correct. And because it's almost correct, I could select here a tile and work with it until I get an approximation of the position that I want. So I can see here that the position could be about 0.97 and minus 0.485. So these will be the values that I'll pass on the tile generator. So 0.97 and 0.485. The reason that for me, most of the time, the size of the tile doesn't work is because I normally have the tiles overlaying each other by maybe 1 pixel or another. So generating the board with this custom offset, we can see that it looks quite nice and quite better than the other value. Another thing is I'm going to be changing the background color here, so maybe a light bluish color. And if we were to then just change the position of these tiles and we were to generate the board again, you see that it's offset with the tile generator transform. This happens because, well, here we're using transform.position. If we want the board to always follow the tile generator, we can change this to local position. Now, whenever we generate the board, we can see here that it is aligned with our tile generator. Okay, now if we were to press play here, we can see that now it looks like quite a mess. This happens because we're not setting any order in the layer, and we're also not setting any Z order according to the Y position of these tiles. To change this, we're going to be positioning our tiles according to their Z position. And if we were to look at the camera on Unity, we can see that the position of the camera is at -10, and whatever is closer to the camera is going to appear in front of the other objects. So if we were to say that this tile right here has a position of -9, you can see that it is in front of our camera. And if we were to say that the tile is at -11, we cannot see it anymore on our camera because, well, it's behind our camera, so the camera can't see it. So if we're going to be using Z to order all of our tiles, what we're going to need is that this Z position doesn't exceed -10, and for the tiles at the front to have a Z position that is closer to the cameras than the tiles at the back. We can go back to our code, and here what we're going to be doing is we're going to get a number between 1 and 0, and this is important because this is kind of a background layer, so it's going to be behind most of our objects, and if most of our objects is going to have a Z position of 0, then this background should be behind these objects. So it should have a Z position between 1 and 0, okay? To have that, we're going to be using -I plus j, okay? So this is going to be the sum of the column and the row of our tile here, and this is going to be divided by tg dot size dot x plus tg dot size dot y. Because I plus j can never exceed the max size of x and the max size of y, then this number right here is going to be a number between 0 and -1. In order to get a number between 1 and 0 from this, we just need to say that this is going to be subtracting from 1. Saving this, we can head into Unity, and over here, when we generate a new board and we hit play, we can see that all of our tiles are correctly ordered. And if we were to check their position, we can see that the first tile is going to have a Z position of 1, and the last one here has a Z position of 0.33. If we were to then get an object here and place it on the scene, it's going to be in front of all of these tiles. Okay, so here we have our board, and since this still has the link to our prefab, we can then use our prefab with different tiles over here. The last thing we can do in order to organize this better is just to name these tiles according to their position. So instead of having all of our tiles be named tile, they are going to be named tile and their position. So here, new tile.name is going to be plus equal to a space here, plus the I position, plus a separator, plus the J position. Okay, saving this, we head into Unity and check to see if this works. So here we have all of our tiles named just tile, and if we were to then generate a board, now we have all of our tiles followed by their position. And we can have fun making boards of different sizes. So this was it for today, guys. If you found this video helpful, please consider leaving a like. If you have any questions, leave them down in the comments below. And for more videos such as this one, please consider subscribing. Thank you so much for watching. Bye!